Ever wonder how some software just runs so smoothly? Even when you're really pushing it hard, it still works perfectly, no hiccups or anything. Well, there's a lot that goes on behind the scenes to make that happen, and a big part of it is testing. So today on the deep dive, we're going to take a closer look at three specific types of software testing: load testing, stress testing, and performance testing. And actually, you, our awesome listeners, sent us some super interesting stuff about this, so we'll be digging into that today.
That's right. You guys gave us a ton of great definitions and examples, and our mission today is to go beyond just what these terms mean. We want to really get into why each one is so important and how they help make sure the software we all use every day is actually, well, good.
Totally. So we're basically on a mission, right, to cut through all the technical jargon and explain how these different testing methods make our digital world more stable and reliable. Sounds like a plan.
Yep.
But where do we even begin with all this testing stuff?
Okay, think of it this way. Imagine your software has to go through these increasingly tough physical exams, like at the doctor's office. Performance testing is kind of like the big annual checkup. It's a way to see how your software is doing overall under normal conditions.
Okay, got it.
And then, within that bigger performance testing checkup, we have these more specialized tests: load testing and stress testing. These are like specific drills, to push the system and see what it can handle.
I like that, like a checkup for your software. So what exactly happens during this performance testing checkup?
The main idea is to figure out how the application behaves when it's just doing its normal thing, operating within those expected parameters. Your sources call this regular operating conditions.
Right.
It's all about establishing a baseline. What should the response time be? How many resources should it normally use? Basically setting a standard for how well it should perform.
So it's not about like immediately trying to break the software, but more like seeing how well it runs on an average day.
Exactly. And while we're doing this checkup, we're watching things like how much CPU, memory, and network bandwidth it's using. We also check how available the application is and how reliable it is overall.
Makes sense.
What's interesting is that performance testing isn't just about looking at normal loads. We also look at loads below and even a bit above what we expect it to handle, not just right at the edge.
Oh, really? Below and above. That's a wider range than I thought.
Yeah, it's all about getting a really complete picture of how the software performs. So we might start by testing with a few users, then ramp it up to what we normally expect, and then push a little further to see when it starts to slow down or have problems. We're measuring things like how many users can be on at the same time, how many connections the server can handle, and of course, how quickly the software responds under different loads.
So we're figuring out its cruising speed and also where it starts to feel the pressure.
Got it. But why is this basic performance testing so important? Well, for one thing, it tells us if the software actually does what it's supposed to do, and if it's fast enough for the people who'll be using it. It's like checking if it meets the requirements.
Right.
But more than that, it helps us find and fix any performance issues before users even notice them. Think of it like catching a health problem early on.
I see.
And it gives us crucial data to know if our current setup can handle everything, and helps us plan for the future when we might have more users or more demanding tasks. Imagine trying to grow your business without knowing if your software can keep up.
That's a great point. You don't want your software to crash just when your business is taking off. So when does this performance testing usually happen in the whole software development process?
Well, it depends. Some companies use a waterfall model where everything happens in stages, and they do performance testing near the end, right before release.
Okay.
But nowadays, a lot of companies use Agile, which is more about continuous development, and they integrate performance testing throughout the whole process. It's like an ongoing check to make sure everything's running smoothly.
Got it. So it's not just a final exam. It's like having regular quizzes along the way to make sure you're learning the material. Makes sense. Now let's dive deeper into load testing. You mentioned it as a specific type of performance testing. So what's the main idea there?
Load testing is all about simulating realistic user traffic, like what you'd see on a busy day.
Uh-huh.
We're talking about testing a website or application with a bunch of virtual users doing all sorts of things, just like real people would. Your research mentioned this usually happens when a project is almost finished, before it's launched to the public.
So it's like saying, we think we'll have this many users at our busiest time. Let's simulate that and make sure everything can handle it.
Yeah, exactly. We want to find that point where the system starts to struggle under pressure. How many users can be active at once before the performance drops or the application crashes? This is super important for setting what are called service level agreements, or SLAs, which basically promise a certain level of performance to users.
Right, right. So we're intentionally pushing it to the limit, but in a way that mimics real-world use. What specific things are we watching for during this load testing?
Well, we're paying close attention to peak performance. How much can the system handle at its absolute maximum? We also want to know if our servers are powerful enough to deal with that much traffic. And of course, we're always tracking response times. How quickly does the system react as more and more users jump in?
So we're looking for bottlenecks and weak spots before they cause problems for real users. Can you give me some real-world examples of how this load testing works in practice?
Sure. Imagine you're testing a word processor. You could have tons of virtual users all opening, editing, and saving really big documents at the same time.
Great.
Or you could test a printer by sending it a massive flood of print jobs from multiple sources all at once. Another common example is simulating thousands of users checking their email on a mail server simultaneously.
Wow, that does sound like a lot of pressure. So why is this focus load testing so important? What does it tell us that regular performance testing might not?
Load testing can uncover hidden bugs that only pop up when the system is really under pressure, like memory leaks, where the application slowly uses up more and more memory until it crashes, or buffer overflows, which can cause security problems.
Huh.
It also confirms that the software can actually meet those performance targets we set earlier. We get a much better understanding of how much the system can actually handle before it starts to break down. And we can see if we need more powerful servers or if we need to make changes to the software to make it more efficient.
That makes a lot of sense.
Basically, it helps us avoid those embarrassing moments when your website crashes because too many people are trying to buy something during a big sale.
Oh yeah, definitely don't want that. So when does this load testing usually happen?
Like we said, often near the end, just before launch. But it can also be used strategically. Like if you're launching a new feature on your website and want to make sure it can handle the extra traffic. You might also do targeted load tests on specific parts of your application, like the homepage or the checkout process, to make sure those critical areas are rock solid.
Okay, so we've got performance testing for the overall health check and load testing to find that breaking point under realistic conditions. Now, let's get into stress testing. That sounds intense.
It is. Stress testing takes things to the extreme. It's about making sure your system can still function properly, even when it's bombarded with way more traffic than it's designed for long periods of time.
Whoa.
And we also want to see if it will totally crash under that stress.
Your sources were right. This is a non-functional testing technique. It's not about testing specific features, but about seeing how the system behaves in these crazy situations. So while load testing finds that breaking point under what we expect to happen, stress testing is like purposely overloading it to see how it reacts to the unexpected, those worst case scenarios.
You got it. We crank the load way past normal, even past what we think might happen during peak times. We want to see what happens when it's pushed beyond its limits. This tells us about the overall stability of the system, how quickly it responds when it's totally overloaded, and most importantly, how well it recovers if something does break.
That recovery part sounds super important. Like, if it does crash, can it get back online quickly and without losing any data?
Absolutely. One example your source mentioned was intentionally messing with a network by randomly shutting down and restarting different parts of it.
Wow.
It's like creating chaos to see how the system handles it.
So we're basically being mean to our software on purpose.
Well, yeah, kind of, but it's for its own good. It's like giving it a tough training session so it can be ready for anything.
Okay, I get it. So why is this almost cruel type of testing so important?
Stress testing helps us understand what happens when things go wrong unexpectedly. We want to make sure that important data is safe, even if a part of the system fails. And we also want to know if those failures can create security risks.
Ah, because a system struggling to keep up might be easier to hack, right?
Exactly. Like imagine a denial of service attack where someone tries to overload your system to shut it down. Stress testing can show us how well our system would hold up against that kind of attack and what we can do to protect ourselves.
Makes sense. So when is stress testing the most important?
You guys were spot on in your research. It's crucial before any big event where we expect a huge surge in traffic.
Like a big product launch or a concert ticket sale?
Yep, exactly. We want to test those limits beforehand so we don't have any nasty surprises on the big day. It also helps us prepare for unexpected traffic spikes, which can happen for all sorts of reasons. If we know where the bottlenecks are under extreme stress, we can fix them before they cause a problem in the real world.
So it's like a disaster preparedness drill for your software. We're planning for the worst so we can hopefully prevent it from happening.
That's a perfect way to put it.
Awesome. Okay, we've covered a lot. To make sure everything's crystal clear for you, our listener, let's quickly summarize the key differences between these three types of testing.
It sounds good. Remember that big picture we talked about earlier? Performance testing is like the umbrella, covering both load testing and stress testing.
Okay.
The main goal of performance testing is to see how the software runs under normal conditions, everyday use. Load testing zooms in on what happens when we have a lot of users, simulating those busy periods. And stress testing pushes things even further, way past normal capacity, to see how the system reacts to those extreme situations.
And the amount of load we put on the system is a key difference, right?
Absolutely. Performance testing looks at a range of loads, from normal to slightly elevated. Load testing focuses on that point where the system is close to its max under realistic conditions. And stress testing, well, we just crank it up as high as we can.
And lastly, each type of testing checks for different things.
Exactly. Performance testing checks overall things like resource usage, availability, and reliability under normal use. Load testing looks closely at peak performance, how many servers we need to handle high traffic, and how quickly the system responds as more users come on board. And stress testing is all about stability under extreme pressure, how quickly it can respond when overloaded, and how well it recovers from a crash.
Fantastic. So for our awesome listeners out there, remember this. Performance testing for the overall health check, load testing to see how much it can handle in the real world, and stress testing to make sure it can survive even the toughest conditions. Understanding these differences should give you a much better idea of what goes into making software that's reliable and performs well.
Right. And this brings up a really interesting question for you all to think about. As software gets more and more complex, and users expect things to work perfectly all the time, how do you think these testing methods will need to change in the future? Will we need even more specialized tests? Or maybe new ways of combining these approaches? It's definitely something to consider. And if you're interested in learning more, I'd suggest digging into the specific tools and techniques used for each type of testing. It's a fascinating field, and who knows, maybe you'll even become a software testing expert yourself someday.